All right, it's 7 o'clock. We'll get started. Thanks everyone for being here. My name's Mike. I'm a field service rep here with Gensco, supporting and training American Standard products. Today we're going to go over the 824 thermostat. So we're going to go over some of the installation information and startup and things you should be checking and some of the advantages to using that thermostat and how to really manipulate it to work best for you and your customers. All right, if you do have questions at any time, please throw it up in the chat. Just type it in there, and that way we can kind of address those as they come up. All right, here we go. Main things we're going to go over today, like I said, installation of the stat, wiring it up, proper setup of the stat. I think that's the most underutilized section. There's a lot to the setup you can do to really adjust this thermostat to work best for you and your customers, and then understanding what some of those options are when you're setting it up, because it's a lot of confusion out there, a lot of just people never been explained. If no one's ever told you, then you don't know, and that's not anyone's fault. And so let's just get that out there. Let's get that education out there. This is the stat we're talking about. You've also probably seen it if you are an American Standard or a Trane dealer. We was our kind of go-to 24-volt thermostat. This is our top of the line 24-volt stat. Everything I'm going to go over today is in the installation instructions. And if you ever looking like, hey, I know Mike talked about this, but I don't remember where it was. Well, just like any good book, it's got a table of contents. So any topic you want to go over is going to be in here. And it's really great, really thorough, it's a very thick book. There's a lot to it. For an installation instructions of a thermostat, having over 40 pages is quite a bit to digest. But as I'm going to show you today, some of this is just, I don't want to say filler, but repetitive. And so the more you dig into it, the more you understand it's really broken up really nicely and easy to navigate, easy to utilize all the information that's in here. So this thermostat is a 24-volt stat. It does recommend using 18 gauge wire solid core. We are using a power consumption of 7 VA. This comes into a play when maybe we were doing zoning of some type. If you're using 24-volt zoning, sometimes you do have to upgrade your transformer to handle that extra power usage. This thermostat does have, like I said, a lot of capabilities, 5 stages of heat and 2 stages of cooling. We can do heat pump. We can do AC with gas heat. We can do dual fuel heat pump with gas heat, heat only, cooling only. It really works in pretty much any 24-volt application I could come up with. It's got a solution for it. So the stat does not require American Standard or Trane products to work. It'll work with any 24-volt piece of equipment, which makes it very versatile, very useful. I've even had some dealers purchase one of these stats to keep as their office stat, as their service stat, and they will send that out on a job they're having troubles with. At the very end of the day, I'll kind of go over what some of those advantages are and how we can utilize this thermostat in ways that are really thinking outside the box, I think. This is actually a picture of the backplate. The difference between this picture and the reality is all of these labels up here are stickers. Then you have your terminals where you put your wires. There have been some times I've seen where the sticker is not perfectly lined up with the holes. And so I always like to count, 1, 2, 3, 4, 5 numbers over, 6 pins over to get to my correct terminal. So do keep that in mind. I have seen people where the stickers are just slightly off and you're not sure, is it the one on is the G right here or is it right here? Which one is it? Just make sure, utilize the stickers, but they are stickers. They are put on by humans, and so they can be off just so slightly. So it is important that you pay attention to where you're putting your wires into the screw terminals. Obviously, we have a lot of places to mount this thing. We got 3 mounting holes. It is required to put one on the left, one on the right. You do have a third hole that's optional just to help stabilize that backplate if it seems like it's not super secure. So this is where a lot of the the bulk of the installation instructions that take place. We have wiring diagrams that are going to show off pretty much every application you're going to come up with. It's really cool because this is helpful, and I've even used this when people have called into tech support, because I've taken pictures, screenshots of some of these diagrams that are going to be labeled in here and sent those off to somebody who's in the field having trouble trying to figure out how to wire it. And so all these ones here, the first group are heat cool only, so outdoor cooling, and indoor, either electric heat or gas heat. The second group, there's groups, is broken down. These are heat pump options. So pretty much heat pumps with electric air handlers. Now you're only going to see 24-volt equipment listed here because this is a 24-volt stat and it can't do any communicating options. So just keep that in mind. And the third group here is dual fuel. So if we do have a heat pump with a gas furnace, how do we wire that? How do we set that up? It goes over that for you, which is really handy. And here's a picture of what that would look like. Here's a dual fuel application, and it shows, I really like how they break it down. So on the left here is your thermostat, the A24 thermostat, and it shows every terminal that is available on there. And then it shows the ones we're going to use. So in this case, we have a single stage or a two-stage heat pump with a variable speed gas furnace, in this case, maybe an S9 V2 or even an S8 V2. We're going to hook up R, obviously. We need R, it's a heat pump in the outdoor unit. We need 24 volts. We're going to hook up common. We need common from the indoor unit to the stat and to the outdoor unit. In this case, we're going to hook up O. You're going to notice here this is kind of different. Y1 is actually going to bypass the indoor unit in this application, and so is Y2. Now, there's a reason for that. When we get down here to the BK, we're using BK in this sense, and BK is a fan control option. If we are not utilizing BK, then you're going to need to wire up Y1, Y2. You'll also notice in this application, we're not hooking up X2. This is your auxiliary heat from the outdoor unit. Now, there's a reason why you don't need to with this thermostat. The really cool thing is, when this thermostat's in heating, you're going to get R and common hooked up, you'll be sending a Y signal to the outdoor unit. When it goes into a defrost, it's going to energize O. When it energizes O, the thermostat's going to see that. And when it sees O energized with a call for heat, it knows it's in defrost and it's going to kick on the auxiliary heat for you. So that's really cool. Now, if we don't have BK hooked up, we need to hook up those other things. But BK will allow it to control the fan through the thermostat and not necessarily just from some preset setting on the furnace. If your furnace is BK enabled and you have a BK enabled thermostat, it does give much better control of the fan. You get fan staging, ramping up and ramping down to help utilize more comfort in the house and better efficiencies out of your outdoor units. It does have some things down here. ODT, outdoor temperature sensor. Outdoor temp sensor would be required if you are going to be setting any lockouts on your heat pump. So if we do have a dual fuel application, I would definitely want an outdoor temp sensor wired in. The other thing down here at the bottom is the remote sensor. That is, sometimes we install our thermostats in places and it's maybe not going to be the best location for sensing temperature in the house, but it's a great location for where they want the thermostat. I've seen them in mechanical rooms, and they don't always, so not every homeowner wants a thermostat just on the wall in their living room or whatever. And so we can use a remote sensor, a wired remote sensor or a wireless remote sensor. But if we're using a wired one, this is where it would land. It would land right here on the RS1. And we can put that wired sensor somewhere else in the house. And that could give us, it won't, and those wired sensors don't have any lights on them. They're just a white little sensor that'll sit on the wall. It's about 2 inches by 3 inches, very discreet and out of the way. Other than that, you're noticing here, I mean, this could be a single stage or a two-stage furnace, hence the dotted lines. Single stage or two-stage heat pump, hence the dotted line. It gives you all of those options kind of built in there. But do know this, if we are not utilizing BK, you are required to hook up the Y1 and the Y2 if you have a 2-stage. Actually, I'm gonna go back real quick. It also has little descriptions here. So if we're using BK, it talks about you're hooking it up. Don't forget to cut the jumper. And there are some older units that require a dip switch to be switched. For restricted mode, like I talked about, if we're doing any type of lockouts on the heat pump or on the furnace, it is required to have a wired outdoor temp sensor. The internet will not work for this. You will be required to have an outdoor temp sensor wired in. And X2 is not required in this configuration. X2, like I said, right here, the little 3. X2 is the auxiliary heat from the heat pump. Because this stat understands reversing valve is going to be energized in a cooling operation, which is our defrost, it knows when it sees that signal to kick on the auxiliary heat. The installation wizard. This thermostat, just like most thermostats nowadays, does have an installation wizard. I'll be honest, I still use it every time I touch one of these thermostats, setting them up, because I find it simple. It forces you to not skip any steps. And so you are quickly and easily going to go through everything that is required to get this thing set up. So say the time and date, very simple. It's going to walk you through the installer setup. After you have the system configured for what the equipment is and all that, it's going to go through service reminders. You can set a reminder to change the filter, a reminder to have maintenance on the system, a reminder for UV light replacement, humidifier pad replacement, all that. You can set up any reminders you would like on this system, which is great. And then at the very end here, it does ask you to put in your dealer ID into identification code, your dealer code. If you're not sure, the dealer code is your company's phone number that is registered with American Standard or Trane. All right, we had one question that came up real quick, which was about the 4.01 air code, which is no outdoor temperature sensor when using Wi-Fi for outdoor temp. So yeah, it will display, if you're hooked up to Wi-Fi and connected to diagnostics, it will display an outdoor temperature based off a local, whatever, zip code you put in there, but it does not use that, temperature that it sees from the Wi-Fi for lockouts. It is purely for looks. It shows weather, upcoming weather for the next few days. It shows, all kinds of like that, but it does not utilize the Wi-Fi temperature for lockouts, and it will give you an air code if you're trying to set a lockout on something. So that CFG 4.01, I think, is usually more on communicating stats. And communicating stats, if they have a communicating outdoor unit, do have a built-in outdoor temp sensor. But the 24-volt mode unit is required to have an outdoor temp sensor. Thanks for that. That's one thing we get a lot of calls on, so I'm glad you're bringing this up, because that does happen quite a bit. People assume they can use the Wi-Fi for their outdoor temp sensor, and they cannot. Smart optimization. You got 28 minor alerts on your diagnostic site. We'll go over that at the very end, some of the diagnostics you can see with this. Smart optimization. This is a call we probably get, not that often, but we do get it, once every couple of weeks. People are asking questions, what is going on? So this thermostat, some thermostats out there will say they're learning or they're a smart thermostat, all that. So this is part of what that talks about, okay? So it's equipped with this program that is going to run the fan for 90 minutes. And it's going to do this twice a year. The first time it does it is usually the next day after you install it. Here it says 18 hours, approximately 18 hours after initial power up. And it's usually going to happen in the morning. Sometimes it'll happen in the afternoon, depends on the time of year. They try and do this once in the spring and once in the fall as a learning thing, to learn how quickly this house is heating up and how quickly this house is cooling down, depending if it's, spring or fall. And it's going to run the fan for 90 minutes straight, regardless of how they have their thermostat programmed, if they're running their fan at all. And so when it's doing this smart optimization for 90 minutes, heating is disabled and cooling is disabled, and it's just going to be fan only for an hour and a half. They do this, usually it's around like 10 in the morning or 11 in the morning, something like that, where it's happening after we've already had our morning heat up or cool down, and it's just, we're usually in a time period where there's not a lot of heating or cooling is required. And it does this twice a year, every year. And so if this is a problem, you can disable smart optimization. And it talks about how to do this. This is a picture right out of the installation instructions. So if you're not sure where to find out where to do this, you go to Home, Smart Optimization, and disable and press Apply. Really simple to disable it. It does help the thermostat know when to come on and when to turn off, so we're not overheating or overcooling or coming on too late. It helps the thermostat learn and be more accurate for homeowner comfort. But if this is something that you think is going to be a problem for your homeowners, I would disable it. It just was going to make sure that your thermostat is working at its optimal performance, keeping this learning constantly as our seasons change. Because let's be honest, you know, what we need for heating and cooling in May is not the same as we need in other times of the year, and so learning constantly and changing and adjusting is important. All right, now we get into the meat of this. This is where people really get hung up, because there's a lot, and I mean a lot of options in the installation setup. We're going to start off in group one. Group one has what everyone knows how to do, pretty simple stuff here, right? What is our outdoor unit? What is our indoor unit? How many stages? So pretty simple. Your outdoor unit's going to be, you're either going to have no outdoor unit, cooling only, or heat pump. Pretty simple. Stages. Remember, this is not communicating thermostat. This is a 24 volts. So you're going to have two options, single stage or two stage. Compressor type. So we do have, if you select two stage, it will then give you this other option that will not be there if you select single stage. So this is important. As you go through this, your options are going to populate depending on what you choose. But single compressor two stage or two compressor two stage. Now this will change. There are some things that change when you have single compressor two stage or two compressor two stage. When you have two compressors, you're going to have an off time in between it. If you have a single compressor, there's no off time. And so that can affect how the system's going to run, what it expects to see, what it's going to do. And that's important that we get that correct. Then we move to the indoor type. Do we have a gas furnace, an oil furnace, an electric furnace, a hydronic furnace? What do we have for an indoor unit? It can control them all. Let it know what it's going to be, and it helps it know how to best utilize. Because if we have electric heat, it's on instantly, right? But if we have gas or oil, it takes a while to heat up before we actually have heat. So knowing those, the type of heat we have, tells it the kind of blower algorithms we need. Indoor heat stages, right? We're going to have 1, 2, or 3 stage heat. There's no mod furnace, mod heat in here, because mod heat is only for communicating. So up to 3 stages we can do with this unit. So 3 stage, you probably not have 3 stage gas heat. There are some 3 stage gas furnaces out there, but 3 stage electric is very possible. Blower type, variable or non-variable. So this is really critical here. If we are going to use that BK terminal, which not all furnaces have, but if they do have it and you are going to utilize it, you have to tell it that we have a variable speed furnace. If it thinks it's if you put in variable speed furnace, but it's non-variable speed, it's not going to function right, because it thinks it's controlling it with the BK. So we got to make sure that we are telling it either variable or non-variable based on what we're using. Switchover valve position. Like I said, this can work with pretty much any piece of equipment out there that's 24 volt. All of American Standard Venturion products, they come as a switchover valve. People usually call it reversing valve. In the cooling is what we do. We engage our reversing valve in cooling. There are some brands out there, I don't need to say who they are, that they will engage in heating. And so this thermostat can work on any brand because we have the option to switch it. Next is cycles per hour. Cycles per hour is, I think, one of our more underutilized options here. It's because people don't understand what that means. I do have some pictures we're going to look at in here at the end of this to show what that physically looks like when we're doing cycles per hour. But cycles per hour can really affect your indoor comfort, as well as kind of the efficiency of the system. So if we are doing 6 cycles per hour CPH on a cooling on a single stage AC, that's going to be a lot of cycles per hour. That means it's going to come on and turn off, on and turn off, on and turn off, on and turn off 6 times per hour. That's its target. That's what it's trying to do. If we set it just 2 cycles per hour, it's trying to come on for 15 minutes, off for 15, on for 15, off for 15. That's its target. It never wants to run more than 2 times per hour. Can it run more than 2 times per hour if you have 2 cycles per hour? Absolutely. But it's not trying to. It's trying to learn so that it doesn't need to do that, that it can only run twice an hour or 3 times an hour, 4 times, whatever you set it for. It does come default, as you can see here, with 3 cycles per hour for all of our compressor stages operation. Heating cycles per hour is going to really greatly depend on if we have gas heat, oil heat, electric heat, hydronic heat. That's going to really depict, it's going to change a lot based on what type of heat we have. So if we have a 80% furnace, we might have 5 cycles per hour be all right. With a 90% furnace, we want to make sure we fully heat up that primary heat exchanger, so we're condensing only in the secondary. And so we might put that to 3 cycles per hour. All right. Group 3. These are our sensors we can have on this thing. So we have some built-in sensors and you can add some sensors. So obviously here is outdoor temp sensor. You have to, it's going to come default with no outdoor temp sensor. If you add one in, switch that to remote outdoor temp sensor. It allows it to utilize that for lockouts. Calibrate outdoor temperature sensor. So if you do put an outdoor temp sensor and you feel that it's reading off, you put a thermostat right, or a temperature probe right next to it, and it's off by 3 degrees, you can go and calibrate that at the thermostat. You can change that. So that makes that really nice. You don't have to go and throw away that outdoor sensor and get a new one, put it on there. You can just calibrate it from the thermostat, 5 degrees plus or minus. It's a pretty good range for an outdoor temp sensor. They're usually within a couple degrees, so you can really dial that in if there's some concerns. Indoor temperature sensor. So like I said, you can wire in a remote indoor temperature sensor. There's one time where I personally had to install a thermostat, one of these, in a kitchen, because that was the only place we could get the wiring to. And then we put another temperature sensor, a wireless one, down in the hallway. And I told it to use the remote indoor temp sensor and not use the onboard sensor. And that allowed us to not be using the thermostat in the kitchen for sensing the whole house. We were able to put the wireless sensor in a better location, but we couldn't get wires into the hallway just because the layout of the house. And this allowed that to happen. We've also had one of these thermostats in a mechanical room, and they put a remote sensor somewhere else in the house. This is where you select whether you're using the onboard sensor or the remote sensor. And once you get past that, if you don't have a remote sensor or you are using it, you can still calibrate the temperature and humidity up to 5 degrees plus or minus, or 5% on the humidity plus or minus. So if you feel like you put a remote sensor in and it's not reading accurate, or you feel that this thermostat's not reading accurate, you can adjust that. You'll notice that when you put this thermostat in, it's at -1 degrees usually right out the box. They do that because they calibrate them before they leave the factory. And if it's off by a degree, they adjust it. So there you go. Group 4 is our accessories. So I don't want to flip back and forth through all these slides, but there's 2 accessory terminals or auxiliary terminals, 2 sets of them on this thermostat. So with 2 sets of auxiliary terminals, we can control 2 different accessories with this thermostat. And so if you want to, you can, if you need to run like a switch to turn on your air cleaner, like some Honeywell ones where you needed a switch till it turn on, turn off, you can do that. You can tell it's got an air cleaner, but you can also tell it's got a media filter, and that's going to help decide your cleaning cycle. So if it knows it's a media filter, it's going to probably do every 3 months. If you got an electronic air cleaner, it might be once a month, every 3 months, every 6 months, depends on what type it is, and you can configure that. Humidifier. Did we install a humidifier in the house? Yes or no? And once you do it, if you say yes, then it's going to want to know, well, did you wire to auxiliary 1 or auxiliary 2? Is it a bypass humidifier, or is it a steam humidifier? And so all these humidifier options here go away if you say no, none installed. But if you say there's one installed, it wants to know what type it is. Are we controlling it? Are we using relative humidity control? Are we using frost control? Frost control is going to try and keep it from checking the outdoor temperature to make sure we're not getting condensation on windows. Humidifier fan action. Are we going to only humidify when we have an active call for heat, or do you want to be able to humidify without a call for heat? So just the fan only. So you can select that. I personally usually go with, especially I'm in Oregon, without a call for heat. So it can do it with the fan only or with the call for heat, it'll humidify. There is no option to humidify when we have a call for cool. That's just not an option. I'm sorry. Once you do set that up, if we are using a variable speed blower, if you selected variable speed blower up in the first group, it then allows airflow during humidifier only mode. And so you can set that from 35 to 100% when it's fan only on the humidifier. Can the auxiliary terminals be dry contacts or powered contacts depending on type of accessory? So they're always dry contacts, Brandon. Those are always dry contacts. That's a good question. So when we are using these accessories, these auxiliary contacts, you have to supply power to them. These contacts on the board, on the stat, are only rated at 24 volts. You cannot put high voltage to them. You cannot put 120 volts. So you can only use 24 volt controls through here. One thing I personally will do is instead of running a whole another wire to get R out there to the stat, just to bring it back on another 20 on another wire, I will just jumper from R over to AUX1, just at the stat, put a jumper there. And then I only got to use one wire to go tell my equipment to turn on because it's always got power there, like the normally open dry contact, and it closes on a call. I hope that answers that. But that's just FYI, you don't really need to run another wire there. You can just use a jumper because we're just putting 24 volts to something. UV lights. Some UV lights, they're going to want to turn off when the fan's not running, right? And so we can use this right here to tell it to turn off and on the UV light. This is group 1 or group 4. This is page 1. We have more. Here's all the other accessories you can do. So now we can also do ventilation. So if you want to do some type of fresh air, right? Some people use this just for like a single damper to open up a 6-inch, vent for fresh air. Some are running this to go over and power up like an HRV or something. Depends on what you want to do. You can configure it however you want, set it up. But if you have ventilation installed, you say no, all the ventilation options go away. If you say yes, then are we using AUX1 or AUX2? You got to tell it. Minimum ventilation runtime. So how many minutes per hour? Anywhere from 0 to 60 minutes per hour. How often do you want to ventilate? So you can be running for only 30 minutes out of the hour, whatever you want to do. You can have an outdoor temperature override. So this is going to help customer comfort, right? So we're going to use this to lock it out and shut off ventilation when we're below a certain temperature. We may not want to ventilate when we're below freezing. Bringing air in from outside that's 25 degrees may not make the customer happy in the winter. And at the same time, we have a maximum outdoor temperature. We can lock it out. When we get above 90, 100 degrees, you can say, I don't want to bring in that outside air because it's too hot. And I'm trying to cool the house. I don't want to bring in 105-degree air. So you can lock it out. So those are really handy, but those also require an outdoor temperature sensor. So if you're going to do ventilation and you want to do an override like this, you are required, even if you don't have a heat pump, to wire in an outdoor temperature sensor. Accumulate overridden runtime. So if we do override and we do block it out, how do we want to make up that? So there are a lot of options here. I don't want to go over all of them, but some of these are ASHRAE 62.2 standard for what is required, right? And so you can just set it for whichever one you want to do, to how do you want to recover when we had to lock out because it was too cold or too hot. You don't have to follow the ASHRAE requirements. You can do whatever you want on these. So that's kind of nice. So those are the ventilation options. A lot of control, a lot of options there. Dehumidifiers. I don't see a lot of dehumidifiers here in the Northwest. Does not mean they don't exist. But this thermostat is used all over the country. This is a lot more common down on the Gulf Coast. They use this kind of stuff a lot down there. But dehumidifiers, we can install a dehumidifier. Again, you got to tell it what AUX it's wired to, and how do you want to use it? Do you want to use it with a call for cool only, or do you want to run it with the fan? Your decision. Yeah, I'm not going to go too deep into that. I don't see a whole lot of dehumidifier use in our territory, in our area. If you do have a dehumidifier in the house and you want to control it through the stat, you absolutely can. It's going to use the onboard humidity sensor in the thermostat to control a dehumidifier or humidifier. Okay. Group 5, there's a lot of setup stuff. That's why I said this is it gets really deep, and a lot of people ignore a lot of this stuff. So I wanted to make sure that you guys are all well aware of all these options that are in here. This one can be very confusing. This first one here, group 5, enable dehumidification. So it comes out of the box enabled. What does that mean? So dehumidification will, if we have a variable speed fan, it will reduce indoor airflow and maintain our single stage or two stage cooling operation when we're within 2 degrees of set point. That's a lot. So let's just say this. If our set point, your cooling set point is 72 degrees, anytime you're between 74 and 72, it will allow the thermostat, if our humidity is above the set point, the relative humidity set point, I apologize, tongue-tied this morning, it will lower the fan speed by 30% to better dehumidify the house. So that's what dehumidification is going to do. Sometimes it is different than enhanced mode. It will, well, it's part of enhanced mode. Dehumidification is going to just cool until we get, or not cool, it's going to dehumidify and lower the fan speed until we hit set point in the house. Now you can set it for dehumidification overcooling, so we can actually go below your set point to continue to dehumidify. I warn you with this, and I know this from experience. I've had this happen to myself where I had dehumidification enabled and it continued to cool, and I had an overcooling limit to 2 degrees to see what would happen. And it got cold in my house. And eventually, because I was bringing in cold air with low airflow, I iced up my coil. So be careful with that. No, I mean, your homeowner has to be aware of it. If they try and turn the temperature in the house down too low, or we have an overcooling, I think my cooling set point was set to 70 at the house. It overcooled by 2 degrees, got down to 68, and I was running only 70% airflow. Well, that caused a problem. It was a perfect storm of I was cooling too cold and I was low fan speed, like low airflow. Those come and for an extended period of time because it was warm out. All those things added up to I froze up a coil. Nothing wrong with the equipment. I was trying to do something that should not be done, trying to cool in a very in a way it's not designed to do. So I'll say this: if they're trying to turn their temperature below 74, dehumidification may not be a good idea. Smart continuous fan. Smart continuous fan is when it sees high humidity in the house, it will turn off your fan even if you have continuous fan turned on. So that's what that is. Disable it, enable it. I don't care. It's one of those things where if you have a really humid house, running the fan's going to spread that humidity around. They don't like that, I guess. So you can disable that. Control response rate. Control response rate, something we're going to get into here after all the setup. We build everything based off something called load value, and this control response rate is a way to build that load value faster. And I don't want to dig into that until we get to that part where we go over load value. Aggressive recovery. So there's multiple ways to recover. So if your homeowner has a setback, especially if that setback's more than 2 degrees, how we want to heat up the house or cool down the house. I'll say this. There's two ways of doing it. I have one I prefer. Aggressive recovery by 2-degree set point change. So if it's more than 2 degrees, it's going to disable a 10-minute staging inhibitor. I'm going to go over that here in a little bit, but that's just saying every time we're more than 2 degrees, it's going to upstage faster. Okay. That might be good on certain applications, certain customers, certain homeowners. That might be a good way of doing it. The next way of doing it, you have an alternative, is heating aggressive recovery by outdoor temp. I prefer this mode personally because if it's a mild day where maybe it's 60 degrees outside, I may have turned it back to 3 degrees, or I have I have about a 4-degree setback at night for myself. I don't want it to jump to second stage because I'm probably going to overheat the house on a 60-degree morning. So I like aggressive recovery by outdoor temp, and I can pick a temperature right here, the next one down, of 0 to 70 degrees, and I can tell it to turn up or stage up only if it's below 40 degrees outside. And that way I'm not hitting aggressive recovery. I'm not staging the second stage heating unless it's really cold out. I prefer that mode. So, and then there's warm air discharge. This one is very rarely used, and I wish it was used more often. I think you get a lot more happy customers, but you have to know your equipment and make sure that it's your airflow is set correctly. Warm air discharge. So this allows if you're a heat pump, it allows it to run 80% fan on startup of heat pump, and that only works if we have a variable speed motor and BK is hooked up and the jumper is cut. It allows it to kind of really get a lot warmer air out of your heat pump because you're going to run a little bit lower fan speed just to kind of get that coil even hotter. Again, know your customer, know your system. It will it can be a great way to people that are saying that, hey, this heat pump's not as warm as my old furnace, what my gas furnace used to be, or my old oil furnace used to be. You're right, it's a heat pump. It won't be. Oh, it's all the time at 80%. And that way you have, sorry, the question is how long does it run at 80%? It'll stay that way. And so that is a way you're really going to get some warmer air out of your heat pump. So certain customers, that could be really great. I don't want to, some people are more sensitive to that, right? So if we're going from a single stage gas furnace going to like a 2-stage heat pump, we might want to do something like this. But still, make sure your fan speed's set right. Make sure we are able to maintain airflow. Make sure we're able to maintain pressures in the system. Don't just set it and walk away. Run it, test it, make sure we're not having any pressure problems due to airflow. Group 6. So this is stuff that I would say most people blow through this page, this group 6. There's only one more group after this, but group 6 is something people bypass a lot. And because there's a lot to it. And I'll be honest, most of the time it's not all that necessary, but my goodness, let's take a look at this. There's a lot here. You'll notice that there are shaded areas and white areas. It's just so you can differentiate between each of the groups. But if you look at this, the shaded area says VS blower, VS blower, VS blower, VS blower. The white areas, non-VS, non-VS. So if we have a variable speed fan versus a non-variable speed fan, your options are very different. And if we are going to run a variable speed fan with BK hooked up, it gives you a whole lot of fan options to help better provide comfort to your homeowners. This may sound silly sometimes, but we can bring on an AC, as you see here, 7.5 minutes at 80%, and then it'll go up to 100%. You can go 4 minutes at 80%. 1 minute at 50%. You can do lots of stuff. I personally just go enhanced mode where it's going to stage up automatically, but you can do this stuff. If you have a non-variable speed motor, still the cooling on delay, you can have no delay, a 15-second delay, or a 30-second delay. Now this here is going to be just no blower for 15 seconds. So that could be a problem. I've seen some depends on how your homeowner uses their equipment, or that could trip a low pressure cutout if you go 30 seconds with no indoor fan, right? A single stage unit, they're cooling on a mild day down to 65, yeah, I can see 30 seconds of no fan tripping a low pressure cutout. So if our homeowner's using it in a way that's not designed to be run, these could be problems. Then we have a cooling off delay. A lot of options. So we can run the fan at 100% for a minute and a half or for 45 seconds. We can run it at 50% for 30 seconds or a minute and a half or 3 minutes, 30 seconds to 35%. These are all ways because once your cooling shuts off, once your compressor shuts off, remember this is 24-volt mode, not variable speed equipment. This is just 24-volt single stage, two-stage equipment. That coil is still cold. Why not get a little bit extra cooling into the house? Why waste that energy? And if we run it at 50% or 35%, you're going to be running really, really low airflow. Homeowner's not going to feel it. And if you're running a low airflow, like that 50%, it's not really going to be cooling the house. We're going to be running a lot more dehumidification though, which will provide better homeowner comfort. Obviously, we got the variable speed blower on delay for heating. So do we want to run lower? Like I like this one that's 1 minute at 50% to let that coil get hot. Instead of going that previous, go back real quick, the warm air discharge, instead of doing something like that, I prefer doing something like this. The variable speed blower on delay for compressor heating. And I might run at 80% for 4 minutes. Let that compressor get fully heated up. And then you can ramp up to 100%. Now that we have full pressures, 4 minutes or 7.5 minutes at 80%, I think that's a much better option than just all the time at 80%. I think that'll give you a much better customer comfort. And you can do some versions of that compressor heating with a non-variable speed motor. So if we have like a S8X1 or S9X2 or something like that, non-variable speed motors, you can do some variations of that, which is like a delay by 15 to 30 seconds. Really, this thermostat's set up to do a lot if you have a variable speed motor. So then you have your compressor off delays. Same thing. We have a hot coil. Do we want to just shut off the fan as soon as the compressor shuts off, or do we want to get all that heat in the house? I usually like to get all that heat in the house. This is still group 6, blower delays. And this goes into if we have hydronic, and then compressor low stage airflow. Here we have 2-stage. If you have a 2-stage unit, you can adjust your first stage airflow. You don't have to run it just, some preset setting. So if you find that first stage, maybe we want to run lower fan speed or even higher fan speed, you can do that. I would say run your equipment, know your equipment before you go adjusting this stuff. Run it with where it comes preset from the factory. And if you find that airflow is too low or too high, you can go in there and adjust first stage airflow, which is pretty awesome. That you are required to have a variable speed motor with BK hooked up to make that work, but you can absolutely make that work. You can absolutely change first stage airflow. I don't know any other option where you can change first stage airflow on a 2-stage compressor other than, that's about it. So gives you a lot of capacity, a lot of options. Group 7 is our last group here in the installer setup. And then we'll get onto kind of how some of those load values I was talking about work. Are lockouts. I don't think I need to explain what lockouts are. I think you guys know that. I hope so. This is talking about, are we going to lock out our compressor or lock out our indoor unit, our gas heat or electric heat? And so first group here is auxiliary heat lockout. That's your indoor unit. Typically speaking, we're locking out our gas furnace or we're locking out our heat strips. Remember, this is only if you have that outdoor sensor wired in. If you don't have an outdoor sensor, you do not have the option to set lockouts. Okay, period. So auxiliary heat lockout. Auxiliary heat is your indoor heat, your gas furnace, your electric heat. Second one is compressor lockout. That's locking out your heat pump. So if we don't want to run heat pump, we only want to run indoor heat on a dual fuel application. That's usually where I'm seeing that. There you go. Here's where you're going to set it. Here's your temperature ranges of where you can set them. You cannot lock out your compressor below your, above your auxiliary heat and your compressor heat. They can't crisscross, right? You have to have a gap. They They have to they can't, you can't lock them both out at the same time. So they are adjustable in a range, but you can't move one past the other. Just FYI. Some of these appear that people usually skip. Defrost heater balance points. We have W1, W2, and W3. You can enable or disable, and then you can set that temperature. You've made it work with auxiliary heat lockout with the weather. Well, Brandon, they may have updated the stat to allow that. I have not seen that, but if you can make that work, I know some people have not been able to do that. I don't know what that is. Sorry, someone asked, Brandon brought up that he's never seen the error for using internet weather data for auxiliary heat lockout. Well, there might be a setting in there that I'm just not aware, but if there's a way to do it, that's great. I think it has to do with, I know I can't do it with the ones here I have in my office, but I think there might be something with has to be connected to dealer diagnostics and connected that way. Otherwise, I know it cannot work if you're not connected to dealer diagnostics. If there is a way with dealer diagnostics, I'd have to verify that. Yep, there you go. They have to set up their account. Okay, well, I was wrong then. I'm glad we're talking. Brandon, as pointed out, as long as they're set up on diagnostics, you can use internet weather. Although usually when you're doing the initial setup installation, they're not connected to their account yet because they haven't created one yet. So if you have to come back usually to make that work, that might be why. Getting back to this here, the defrost heater balance points, W1, W2, W3. So what this is referring to is when we go into a defrost, do you want to use, and if you have a gas furnace for backup heat, do you want to use just W1? Do you want to use W1, W2? Or do you want to use nothing? You can actually lock them all out. If you have electric heat, do we want to use first stage heat strips, second stage heat strips, and third stage heat strips? And so you can lock them out. So you're only using as much heat as it is kind of cold outside. So I've seen where people have locked out, they always leave W1 engaged, but they lock out W2, so the higher stage of heat, until it gets down to freezing. And then W3 maybe at 20 degrees. I've seen people lock out your heat strips. If they find that it's just using too much power, and on a mild day when it's 40 degrees outside, we probably don't really need that much heat strips because yeah, it's going to blow cold air in the house, but we're not really heating that much, so it's not a big deal. You have those opportunities. What's really cool to me though is this last part down here. This part that gets overlooked by virtually everyone, including myself for many years. Compressor cooling first stage lockout. Why would we ever want to lock out first stage of the compressor? Well, if you look at the next part here, what your temperature ranges is 80 to 120 degrees. What this means is if we have a two-stage outdoor unit, you can jump straight to second stage cooling when it's really hot outside. So you can lock out first stage cooling above 100 degrees. And then if it's over 100 outside, it'll go straight to second stage cooling. Down here, compressor first stage lockout. Same idea, but when it gets really cold. So I can say anytime it gets below freezing, it comes from the factory set at 50, but I can set it down to 32 degrees and say, hey, when it's below freezing, I want to go straight to second stage compressor heating. That I can see that where that could be useful. There might be some people from Montana here where this is for furnace first stage lockout. We can lock out a gas furnace's first stage and go straight to second stage furnace heating on really cold days. And that would be advantageous in letting the homeowner get that heat and not have to wait a 10-minute delay to get the second stage sometimes. And so that could be something that is very, 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 very helpful under those kind of like an aggressive recovery, but you're doing it this anytime it gets below or above whatever your set point, you can now jump right to second stage. Like I said, it's using something called load value. So what is this? So we're almost done here. I know we're getting close to 8 o'clock. We use a PI control. PI stands for proportional and integral. Proportional, integral. Proportional is the distance from set point. So this line here is 72 degrees and we're below it, right? So we need to heat the house. Proportional is how far off of set point are we? The integral portion, I can't talk still, is how long we've been off a set point, time. Okay. So those two things, distance from set point and time away from set point, equal a number which we call a load value. So when there was a fast control response rate was either normal or fast, what that does is that it shortens this time period of how often it'll add to that load value. So you can speed it up, right? So you can make it get more aggressive with this, creating a load value. Now, a load value will depend on what your load value can be, will depend on what type of equipment you have. If you have a single stage outdoor unit, your load value in cooling will be 0 to 100. That's all it can be. If you have a 2-stage outdoor unit, your load value can be 0 to 200. Indoor, single stage furnace, 0 to 100. 2-stage furnace, 0 to 200. Kind of the same idea. Now let's see what this load value means. A load value of 50 would be a 50% demand for first stage cooling. Okay, if we're in cooling mode. A load, that means on half the time, off half the time. A load value of 150, if we have a 2-stage system, would be first stage, we'll have to run 100% of the time for the next hour. And second stage, we'll have to run 50% of the time for the next hour. That's kind of the calculation, what it thinks to achieve set point it would take. Now we're going to look at this, what it looks like in a duty cycle. This is cycles per hour. So if you had it set for 6 cycles per hour and you had a load value of 50, this is how your system's going to run. Off for 5 minutes, on for 5, off for 5, on for 5, so on and so forth, but it's going to run for 50% of the hour. Now, if you're going to run it at 2 cycles per hour, it'll look like this. Off for 15, on for 15, off, on. Both of these have the same amount of runtime. They're both running for 50% of the hour. They're both off for 50% of the hour. The difference is this one's just turning on, starting to get pressure built up, and then it shuts off. This one, when it turns on, it runs for, it stabilizes, hits our like a good cruising speed for our compressor before it shuts off. The second one here is probably going to give you better compressor lifespan. This one probably not as good for the compressor's lifespan. They come from the factory set at 3 cycles per hour, which would be on for 10, off for 10, on, off, 10 minutes at a time. I'm okay with that. The problem with the 2 cycles per hour is a 15-minute runtime might overcool the house, but it knows it's going to be off for the next 15 minutes. And so you're going to have large temperature swings in the house with a 2 cycle per hour setup. 6 cycles per hour, less temperature swings, but it's going to be not so great on the equipment. So you really do have to think about this stuff. You can't just, I mean, going generic, leaving it at 3 cycles per hour is usually pretty good. But if you find that it's just getting really big temperature swings in the house, we might have to increase those cycles per hour. Sometimes equipment, running the thermostat's trying to maintain these cycles per hour. And so you might have to adjust your cycles per hour to make it not overheat and then overcool the house. So there's more talking about that. Like I just said, lower cycles per hour creates longer run cycles, but the indoor temperature is going to deviate above and below the set point. The higher cycles per hour, you're closer to your set point, but those cycles are going to be on that compressor are not going to be great for the equipment lifespan. Better comfort, not as much happiness there. I do have 5 minutes left before we hit 8 o'clock. I want to show you one more thing. We have one more slide. I do want you guys to scan that real quick while I get set up to show you the last thing, the diagnostic side. If you can scan that with your phone, I'd appreciate it. It's just a survey to see what you like, what you don't like, kind of questions about what you'd like to see in the future with these kind of trainings. So please scan that if you have a moment. I'm going to bring up another screen. And I'm going to show you what diagnostics can look like. I'm going to count to 10 here, and then I'm going to put up the other screen. All right. So I'm going to show you what diagnostics looked like on an 824 thermostat. So here's what you can see. Now this is, oh, lost my screen here. All right. So you can see what the system is doing throughout the day. We're not communicating, so we can't see error codes. We can't see everything. But what I can see is what the system is trying to do. I can see that the system was running at, just throughout the day. I can see the time right down here. It's going to show the time. I can see what time the cooling came on. I can see what time the cooling turned off, and I can see these cycles happening. And I can see this runtime. Now this is what the thermostat's calling for, not necessarily what is being provided. So then you look up here, and it's going to tell us what it sees the temperature in the house doing. So I'm going to turn off some stuff. I see this yellow line here, this dash and dot yellow line. That's humidity. I'm going to turn that off. Gets it out of the way. I see this other, that yellow line was outdoor humidity. This one right here, this other blue line down here, that's indoor humidity. Well, I'm not really too worried about that. Now I got it down to a few less things, and I can now see how the temperature rises. The solid line is the temperature in the house. The top, let me zoom in here. The top dash line is the cooling set point. The bottom dash line, that is your heating set point. So I can see where it rised up, hit the cooling set point, and the AC kicked on, and it kind of maintained at that spot. I can see it kind of overcooled right there. And then it came back up, cooling came on. I can see it running back and forth like that. Now, I see we have a question. Let me just finish this. If the AC is not working, the thermostat will not know. But what you will see is you will see runtime, and the temperature in the house will continue to rise. And so you can see online a blown capacitor. You can see online weird things happening. And I have found many, many problems with the system on an 824, 24-volt thermostat, 24-volt equipment, no communication. Just by being able to see this information right here, we can see when it's doing what it's asked and when it's not doing what it's asked. I can see when a homeowner goes over here and turns the set point down. If you look in the bottom left corner of the screen, it shows the set point, cooling set point, heating set point, and I can see them turning it down. In this case, went from 72 down to 70. Okay, I can see that. I can see my heating set point drop from 69 down to 65. You can see all that quickly and easily. I have found people who are turning their thermostats down to 62 at 11 o'clock at night. Well, and then it runs for 6 hours straight, and it hits a low pressure cutout around 4 in the morning. Guess what? That's not a problem with the equipment. That's a problem with operation with the user. And you can see that on diagnostics with this thermostat connected. You can't see that when you show up at 11 a.m. the next day and the outdoor unit's in a lockout from low pressure cutout, and you turn it on, the charge looks great. Everything looks fine. You can't find that problem. But diagnostics allows you to see that regardless of the brand of the equipment. So you could literally put one of these thermostats on someone's house who's having a reoccurring problem that you just can't duplicate when you're there. I know dealers who have done that with success. It's a very useful tool. So I think that's pretty cool. Just want to kind of show you guys, there are some errors you will get. They're marked down here. It's called an SDA, system diagnostic alert. And if let's say a capacitor blows on the outdoor unit and it's not running, it'll show the temperature rising in the house, and it'll give an alert at midnight saying, hey, we had a failure to achieve cooling yesterday. It can't do it live. It does it as an algorithm looking at the previous day, but it'll give you a failure to achieve cooling or a failure to achieve heating. It'll give you there's like around 30 something diagnostic errors that it can do based off of algorithms. So I do highly recommend, if you install the stat, get it connected to the internet, get them registered with diagnostics, so that way, and make sure they opt in so you can see this. There was one question came up that said, is the test mode easy to use? I find the test mode in the 824 thermostat extremely simple to use. And it's my recommended way to use the system when you're trying to set it up and test stuff. If you notice when I was showing you the cycles per hour, they started off in an off cycle. There's someone who I talked to last week who they turned the thermostat down or turned it up, and it was after 5 minutes, it hadn't turned on yet. Well, they were set up for 3 cycles per hour. It took 6 minutes until it came on. It's not a fault with the system. It's not a fault with the stat. It was in an off cycle in the cycles per hour. If you use test mode, which you get into the same place where you get to your installer setup, you go, menu, service, technician access. Once you get into there, there's a test mode. There's a test group, and you can fire any mode of operation on here. Fan only, first stage heat, second stage heat. If you have 3-stage, third stage heat. If you have 5 stages heat, you can do all 5. If you have 2 stages on the compressor, 3 stages on your heat strips, you can test every single mode that way. And it's reliable because it is doing it as far as every way it can. It's just not based off an algorithm. It's based off of what you're requesting from the system, which is really awesome. If you have, excuse me, a variable speed blower with BK enabled and hooked up, you can check different fan speeds, which makes it really, 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 really helpful for finding those noisy complaints. Customers say, hey, it makes a noise when this runs. Well, you can set it right to that mode and test it right away. So, well, that's what I got for today. We hit an hour. Not supposed to go over an hour, but I just want to make sure you guys are all there. Here is that right here, the QR code again. Please, if you can, scan that and give us a little bit of information how we're doing, if you like it, what we're providing for you. Other than that, I hope you all have a wonderful rest of your day. Thank you for your time. If you have questions, I'll hang out here for a few more minutes. Recommended airflow. We got a question here. Recommended airflow for first stage compressor if we're not doing 80% airflow. I'm not going to say there's one recommended airflow setting. It depends on your equipment. Depends on a lot of stuff, Brandon. I don't want to say here, set every single system for 60% or for 70%. It really depends on the equipment. Like if this is a run true 15 SEER side discharge unit, right? That one needs very specific 80% airflow, right? Other units can get down to like 60%. It depends on what equipment you're matched with. So if you're not sure, by all means, you can reach out to tech support when you have that equipment. Say, hey, what airflow do we recommend on first stage on this specific outdoor unit? And it'll be listed on that outdoor unit in the service facts what it recommends first stage airflow. And so we could then set it up that way.